Welcome back to Quantitative Analysis Practice Questions for ENTR 3140. In the fifth question, we're presented with some information for Jessica's Juicy Jams and Jellies. We know that Jessica sells 3 different sizes of jams, and we've been provided with some information on the selling price, the markup, and the sales mix for the various sizes of jams that Jessica sells. This is a common scenario for marketers, as we typically have a variety of products in our product mix and want to understand and be able to forecast the impact of changes to our mix. What will happen if we sell more of the family value size and less of the sample size? Will our profitability improve? By how much? What about our revenues? In order to develop our strategies and forecasts, it's necessary to be able to calculate the impact the sales mix has on our overall sales and profitability. In order to better understand the impact, we need to be able to calculate and forecast our weighted average selling price, cost, and margin. In this particular example, we've been given the information on the 3 sizes of jams that Jessica sells. We have the selling price for each, as well as the markup and the mix of the units sold. To calculate the weighted average selling price, weighted average cost, or weighted average contribution margin, we simply multiply the measure we're interested in by the percentage share of our mix that product holds. So, for example, to calculate the weighted average selling price, we know that the family value size sells for $10 and makes up 60% of our unit sales. That gives us a weighted average selling price of $6 for the family value size. We can calculate the weighted average selling price for the standard and sample sizes in the same way, giving us a weighted average selling price of $1.25 and 38 cents respectively. Calculating the weighted average variable costs follows a similar logic. In this case, however, we have not been given the cost for each product, so we will first have to calculate the cost by subtracting the markup from the selling price. Once we have the cost by size, we can calculate the weighted average cost by multiplying the cost of each size by its percentage of our sales mix. Now that we have the weighted average selling price and the weighted average variable cost, we can calculate our weighted average contribution simply by subtracting the weighted average variable cost from the weighted average selling price. From here, we can calculate our weighted average contribution margin percentage by dividing our weighted average contribution by our weighted average selling price. So, if Jessica sells her jams in the mix proposed here, her contribution margin would be 57%. At this point, we could conduct a sensitivity or what-if analysis. We use the sensitivity analysis to compare revenues and profitability of different forecasted sales mixes. What if we forecasted the mix to change to 40% family value size, 40% standard size, and 20% sample size? If this were to happen, our weighted average selling price would drop to $6.50 and our contribution margin would drop to 55%. What if we could change the mix to 70%, 20%, and 10%? In this case, our weighted average selling price would increase to $8.25, and our contribution margin would increase to 58%. Understanding the impact of our sales mix and being able to calculate the weighted average selling price, the weighted average cost, and the weighted average contribution margin help us to build plans and evaluate alternative strategies.